Alright, so this is our next set of notes in Unit 4, Congruent Triangles. Like I said, everything in this unit is going to be talking about triangles, so you're just going to learn something else about triangles every other day or however. This is triangle inequalities. So this is another theorem. I already gave you a couple of theorems. You know the triangle angle sum theorem now. You know the exterior angle sum theorem now. You know the isosceles triangle theorem. And you know the theorem about equilateral triangles. This is triangle inequality theorem. Alright. This theorem states that the sum of the lengths of any two sides of a triangle are greater than the length of the third side. Also, the difference of the two sides of the same less that the length of the third side. Then I need to change that. It should be then, not that, but whatever. Still reads good. What this theorem is telling you, it's telling you about a triangle, what makes a triangle a triangle. So it's saying if you know, well, for a triangle to be a triangle, the length of any two sides of that triangle have to be greater than the third side. That has to be a case for a triangle to be a triangle. If it doesn't work out, then it's not a triangle. Because to be a triangle, the lengths have to be a certain way. That's any two sides you add together have to be greater than that third side. If not, if they give you three numbers and that don't work out, then you can't create a triangle with those three numbers. The figure won't connect. Symbolic form. So what they're saying, the symbolic form of that, and we're using this as an example over here, this triangle with side A, B, and C on it. They're saying A and the absolute value of A minus B is less than side C, but side C is less than sum of A plus B. You're not really going to get that right now, but that's going to help you be able to figure stuff out further down. We're going to use it further down. Which ones am I doing? Hold on, I'm just looking at something real quick. Oh yeah, okay. Just deciding which two I'm gonna do. I'm not doing all these. So examples 1 through 4. It says decide whether each set of numbers is a triangle. Not really hard to do. What you want to do, put your numbers in order first. That's what I usually do. So I'm gonna rewrite them as 9, 12, and 15. And I'm going to take my two smallest sides of my triangle and I'm going to add those together. Whatever I get from that has to be greater than that third side. And honestly, this is math you can see, but I'm going to still show it out for you. So 9 plus 12, the situation has to work out where 9 plus 12, whatever that is greater than 15. I'm going to put a question mark right here right now because we ain't did the math yet. So 9 plus 12 is 21. 21 is greater than 15. I hope I don't have to teach y'all about the greater than and less than sign. I'm just assuming y'all know what those signs are. I ain't even talk about that, but I mean, y'all in geometry now. I know you've seen greater than and less than many times before. So in this case, the sum of my two smaller sides on my triangle, how do I know they're my smaller sides? They're the smallest numbers. The sum of my two smallest sides is greater than this largest side, 15. So yes, the question asks, decide whether each set of numbers is a triangle, yes, this will represent a triangle. This is a yes for me. I'm gonna do number 4 real quick too. Number 4, I'm reordering my numbers. Honestly, you don't have to reorder, you can see it. I'm gonna just write them. 2.2 is my smallest side, plus my middle side, which is 12, and put a question mark here for now. 14.3. Add these two together. 2.2 and 12 is 14.2. Over here I got 14.3. 14.2 is less than 14.3. That's the case. They asked me, would these set of numbers represent a triangle? This is a no for me. These set of numbers could not make a triangle. It doesn't meet the triangle inequality theorem. And so it always has to be greater than. I know some of y'all might question, well, what if they're equal? It has to be greater. And it seems like that was Tim's question just now. The thing, look at the top, it tells you greater. It has to be greater than for it to be a triangle. They can't be equal either. So obviously 2 and 3, do those real quick. Decide if they're triangles or not. If those numbers represent a triangle. Lucas on number 2. When you added the two smaller sides together, what'd you get? 19, and then the bigger side was 20. 19 is less than 20, so you said what? Yeah. Devin on number 3. What'd you get when you added two smaller sides together? 23. And the biggest side, you sound like you're guessing. Yeah, no. Has to be greater than that. Alright, so that's pretty much it. And you always check with your smaller size, because I mean, it can't get no smaller than that. Of course, if you do if you add 12 and 15, like say for that first one, if I'd added 12 and 15 again, those are my two largest sides. Of course, that's going to be greater. You need to check with your smaller sides, because it says any two sides of a triangle have to be, that you add together, have to be greater than that third side. So to check, common sense will tell you want to use your smaller sides, because if you use the bigger sides, that's always going to be the case. You need to check with the two smaller sides and see if they're greater than that largest side. So that's checking to see if a triangle is a triangle, if they just give you side lengths and don't show you a triangle. Another thing you can do, given the length of two sides of a triangle, so say I give you two sides of a triangle and you don't know what the length of the third side is. You could at least tell me like what the range would have to be for that third side, what the smallest number possible on that third side would be. A range basically. And to figure out the range, we're actually going to use that symbolic form up here that we had to figure out the range for that third side. So on this one, they give me two sides, 9 and 15. I'm gonna figure out the smallest number first that could possibly work for the third side of the triangle. So 9 and 15. If I'm looking for the smallest side, I'm assuming 9 and 15 are my two largest sides. And then I'm gonna just do find the difference, absolute value difference here. The reason you got absolute value there is because you don't want a negative answer. And y'all should know that absolute value gives you positive answers. It's just asking the distance between the two numbers. So the distance between the absolute value of 9 minus 15. 9 minus 15 is negative 6, but absolute value is 6. And then you want to find the maximum, or how large that third side could be. So you also want to find out, assuming that 9 and 15 are your two smallest sides, what could be the biggest number? And you would just do the 9 plus 15. 9 plus 15, that would give you 24. So this gives me my range. To get the actual range, you need to write your inequality. I'm writing the inequality just based off this up here again too, with C being in the middle, C being that third side. So it's going to be 6. It's going to be less than my side C, and then 24 is going to be greater than my third side. So my range is any number in between. And this is you finding your range. Any number in between 6 and 24 can be used for the third side of this triangle. I think some of y'all don't get what I'm saying, but let me show you. So you remember what the rule said. The third side has to be, the third side has to be smaller than the other two added together. So say if I use 6, I'm gonna just do it down here under. Say if I said 6 plus 9, that's gonna give me 15. 15 equals my third side, which would have been 15, and this would be a no. That's why they're saying the range is any number greater than 6, but then less than 24. If I chose 24, I'll show you how that wouldn't work either. Then I would do 9 plus 15, which equals 24. So those two sides add together equal 24, and then my third side would have been 24. That won't work either. These are both no's. That's why they're telling you your range here is anything in between 6, greater than 6, and less than 24. That would be what the third side of that triangle could be. So that's you finding a range. Alright, some of y'all probably already did it. Find my range on number 6. Wait for them to. Amber, what you got? Yeah, 9 is less than C, and then C is less than 37. So your range is any number between 9 and 37. Can't be 9, can't be 37, but any number in between those. can be represent that third side of the triangle. Good. That'll probably be the hardest thing y'all do today. Everything else is easy. Even this down here. List the angles from triangle ABC in order from smallest to largest. So this is figuring out your smallest angles to your largest angles, or and vice versa. We're gonna do a reverse on the others. One down below too. So the best thing to do for this is draw out a little small triangle for yourself, and it doesn't have to be accurate in size at all, because when you put the numbers on, it's probably not gonna make sense the way you draw it. I'm gonna just draw a random triangle, then I'm gonna label it A, B, C. I suggest all y'all do it too. Side AB would be 17. I'm just using what they got up here. BC would be 21. AC would be 18. Those are the sides. They want me to, like they said, list the angles of triangle ABC in order from smallest to largest. Easy thing to know about angles and sides. Your smallest angle is always across from your smallest side. Your largest angle is always across from your largest side, and vice versa. If you got the angles and you're trying to look for the smallest side, well, I'll talk about that when we get there. Let's just figure this out first. So they want me to go smallest to largest. My smallest side is what, Billy? Billy, what's my smallest side? 17. I'm gonna draw an arrow across from that. That's gonna land me at angle C. Angle C would be my smallest angle. So my smallest angle is angle C. And then the middle side is 18. Go across from that, angle B. And then my largest side is BC with 21 on it. Across from that, angle A. Do number 8. Zoe, what you got as the smallest angle? Angle C. And I'm labeling this one differently too, because I want to show you that it doesn't matter which way you label. It's just putting the numbers in the right spot afterwards. Remember the last one I labeled kind of ABC going around that way. This one I'm just calling it CAB. Don't really matter. It's just after you label with the letters, make sure you put the numbers in the right spots. So yeah, she said angle C is my smallest angle. What's my middle one, Zoe? Angle B. And then largest is angle A. Won't always end up that way, so don't think that's how they're gonna end up. They will be mixed. That's just how these two worked out. So that's finding the largest. That's finding your angles, smallest to largest. Now, you need to pay attention. Sometimes they'll ask you to go largest to smallest. It don't matter. You can do whatever you got to do. For example, down here, they switching it up. They asking for the size now, but instead of saying smallest to largest, they're saying largest to smallest. So it said list the sides from triangle ABC in order from largest to smallest. Draw myself another quick triangle. I'm going to say BAC this time. That's what I'm going to call mine. Don't really matter though, however you want to do it. Angle A is up here, 46 degrees. Angle B is here, 30. Angle C is here, 104. Like I said, this is not going to be drawn to scale. Obviously, the way I drew this angle ain't 104 degrees, but you just need a triangle so you can be able to see what sides are what. Same thing with the sides. Now you just got angles. They want my largest side. My largest side is always across from my largest angle. My largest angle is 104. Across from that is the side AB. My middle, which would be 46. Here, across from that would be BC. And my smallest, across from 30, would be AC. Do number 10. Oh, I like number 10. Tylee. Huh? You don't know what? Let me ask you this. What's missing, Tylee? Huh? Angle B, right? You don't know how to find angle B? Didn't they give you two of the other angles? What's the measure of angle B, Tylee? Measure angle B, man. 60. Alright, so while I go get the dough, go ahead and give me my largest to smallest size, then I come back, have them ready for them. 61 degrees, 60. I'm back, sir. I'm ready. Spin 'em. Tylee, let's ride, man. The largest is, excuse me? The largest is what? What's the largest angle? Yeah, don't look at your paper. I told you I'm label mine different each time to tell you that it don't matter. Look at your paper, don't look at mine. Come on, man, it shouldn't be taking this long. Spit them out. You're killing my video. Jesus Christ, somebody. Emerald, let's ride. AB, AC, and BC. Come on, Tylee. Honestly, the back is for you. Only thing I want to do, let me do that now. Number 12, maybe. But I think you'll know how to do number 12. Let's go all the way to the bottom. Look at number 12 on the back. You'll know how to do 11. So 12 and 11, similar to what we just got for doing. They want you to list the sides from order from largest to smallest. Obviously, you know what doing number 11. That's what we just got finished doing. You got to find that missing angle, and then you can list your sides from smallest to largest. I mean, largest to smallest, excuse me. Number 12. They ain't give us no shape or nothing. They ain't even give us no angles, but they did give us expressions for angle A, B, and C. To be able to list the sides, we first need to find the value of the angles. So y'all need to understand that to do that, we need to solve for X. Luckily, y'all know how to solve for X now, because we've been doing that for the last 2-3 days. You will agree on your triangle, though, that, and I'll make one out here real quick. Angle A, B, and C are all interior angles, yes? That being the case, what equation are we going to write? Lucas, what equation would you write to solve for X here? Yeah. For those who didn't hear him, I'm going to write it out. That's what he said. Yeah, y'all need to solve that for X. I guess y'all gonna make me do it with you. That's fine. There's a lot going on, so I'll go back to boxing. Anybody that's going ahead of us, what you got when you combine like terms? Nobody? 14x. Looks like plus 124. 124, alright. Equals 180. Subtract. Cancels. 14x equals 56, and x equals 4. That's just the value of x. Obviously, we want to find our angles. Measure of angle A. What now? Measure of angle A is going to be 65 when you plug in. Measure of angle B. Louder? No. 5 times, make sure you do order of operation, especially on B. Got to do the multiplication first. 5 times 4 is 20. 93 minus 20. 73 degrees. That's the one y'all got to pay attention to. Some of y'all forget about the order of operations. Multiplication before subtraction. And the last one, say it again? 42. So those are your 3 angles. You can put them in if you want. A 65, B is at 73 degrees, and C is at 42 degrees. And then I'm just finding what they say, largest to smallest, right? So here, oh, that's wrong. Here, there, and there. So I got AC, comma, BC, comma, AB. Those are my sides, largest to smallest. Finish the rest of that page so you can fill out your notes. You can do the rest of that on your own. It shouldn't take you long.